So how does the safe use of hydrocarbons differ to that of handling carbon dioxide? Well, we've asked similar questions to Peter McQueen, a teacher of refrigeration at TAFE, and Kevin Lee, the Global Technical Manager for Heatcraft Worldwide Refrigeration.
What equipment I can retrofit?
No equipment can be retrofitted. Only equipment that has been designed and manufactured for carbon dioxide can have carbon dioxide installed.
With CO2 it cannot be retrofitted because the equipment must be designed for the high pressures of the CO2 itself.
How could I identify equipment containing CO2?
Carbon dioxide is also known as refrigerant R744, so ideally I would look for identification on the system with some labelling. If there is no labelling on the equipment whatsoever, I would treat the system as though it contained a hydrocarbon refrigerant that is highly flammable.
The equipment should be labelled with a label saying carbon dioxide or CO2 or the refrigerant number, which is R744. If it's not labelled, then you should exercise a lot of caution in establishing what the actual gas is.
What are safety procedures required for handling the CO2?
Carbon dioxide is classified as a 2RE refrigerant, as all other refrigerants that we commonly use are. So all PPE equipment is applicable, such as safety glasses must be worn at all times, protective clothing, which includes long trousers, long sleeve shirts and safety boots must be worn. It also must be remembered that carbon dioxide is an asphyxiant, which means that it displaces oxygen in the air and can lead to suffocation. So we must work in a very well ventilated area.
CO2 poses several major risks for technicians, and these can be broken up into three areas. Firstly, contact with liquid CO2 can cause cryogenic burns, so you should make sure that you've got all your personal safety equipment there, such as clean dry clothing. These should be a long cotton drill shirt, long trousers. You need to have clean, dry, waterproof gloves or leather gloves, and face and eye protection is critical as well. Secondly, although CO2 is a naturally occurring substance in the air we breathe, it's at very, very low concentrations, and exposure to higher concentrations, for example 3%, can cause hyperventilation, and if it gets up to 10% you can actually pass out into a coma, and if there's nobody there to rescue you, you'll die. So it's very important that when you're entering an area that potentially has leaked CO2 in it, that you wear a personal protection monitor that will send up an alarm if there's high concentrations of CO2 present. And thirdly, you must only use the service hoses and gauges designed specifically for CO2, because it's much higher pressures than the standard R22 or 404A refrigerants you've used in the past. If you use those gauges and hoses for CO2, you run the risk of the hose bursting and causing injury.
How do I reclaim CO2 out of the system?
CO2, or R744 as we know it, is not classified as a controlled substance and therefore can be released directly to the atmosphere.
You don't need to actually recover or reclaim CO2 because it's a naturally occurring substance. But you do need to exercise a lot of caution when discharging the CO2. It should be done into only a very well ventilated area. And there's another risk that as you discharge the CO2 gas, it can form dry ice in the hose. So you should only discharge it from a valve. You shouldn't have any additional piping or hose attached to the end of the valve where you're discharging the gas out of.
How do I store and transport CO2?
CO2 bottles must be stored in an upright position and securely fastened to a wall using suitable brackets. It must be transported in an open vehicle, securely fastened.
CO2 cylinders should only be transported in a vertical manner, well secured, and in an open tray in the back of a utility, for example. They should not be transported in the back of a sealed van.
Why use high pressure refrigerant?
Carbon dioxide systems operate at pressures far higher than we're currently used to with systems. However, it is a natural refrigerant. It has excellent refrigerant properties and has an ozone depleting potential of 0 and a global warming potential of 1.
Although CO2 has very high working pressures and can cause serious injuries, it is an extremely good refrigerant. And as it's a natural gas, it has a very low GWP of 1, and due to this, it's not an environmental risk when used as a refrigerant.